Welcome back to my channel. If you have seen my previous video on UVK6, you will know that I replaced the version 1 board with the version 2.5, including an external antenna for HF reception. After that modification, I ran into an issue. While transmitting, my VHF output power dropped to 0, but surprisingly, the UHF range was still outputting close to 2.5 watts. In this video, I'll demonstrate the problem. I have connected the radio to a dipole antenna through this power meter, and I'll be using live UHF and VHF repeaters to troubleshoot in real time. Let's start with UHF frequency. As you can see, the power meter shows nearly 2.5 watts going to the antenna, and I am also receiving the repeater tail. Now, switching to the VHF repeater, you can see that the transmission LED lights up, but the power measurement reads 0. To understand what's going on, let's take a look at the radio schematic. A huge thanks to the person who uploaded this in GitHub, link in the description. The heart of the transceiver is BK4819 chip, which controls various filters via GPIO pins. The RF output comes from pin 17, PA out, which goes to a RF preamp, then an RF buffer, and finally the RF amplifier powered by the RD02 LUS2 as per the schematic. The output is then routed through two filters. The top one is UHF and the bottom one is VHF. Finally, the signal is connected to the antenna port via SMA connector. While the UHF output is working fine, the VHF output is problematic. There is no power, so we have to look in VHF circuit part. If we closely examine the filter selection, it's controlled by a transistor network driven by BK4819 GPIO pins. The voltage bias is supplied to a pin diode switching network through an inductor. The transistor network uses a dual complementary pre-bias transistor unit UMC4N, and the single pole single throw RF switch is based on a pin diode 1SS381. The RF signal needs to be blocked from the DC bias current, so an RF choke and a DC blocking capacitor are used to prevent the bias current from affecting the RF signal. Looking at the radio PCB, we can see BK4819 chip here and the switching transistors that biases the pin diode over there. The VHF filters and the matching circuit are highlighted here. Now, to troubleshoot, I check the DC voltages while pressing the PTT button with the VHF range selected. Using a multimeter in DC voltage mode, the voltages I measured at the key points, including GPIO4 and the transistor network output, were correct 5 volt. Interestingly, while transmitting in VHF without the chassis and the heatsink, I could feel warmth from the RD02 LUS2 surface. Assuming the VHF filters are fine, I next check the antenna. Recall that I replaced the inductor parallel to the antenna with a 100 microhenry inductor during the version 1 mode, but switched back to the SMD inductor for the dual antenna setup in the version 2.5 mode. This inductor is in parallel with the antenna, so the antenna should be DC short and potentially having some parasitic RF effects. I used a digital multimeter in continuity mode to check the inductor. It seems the wire wound inductor failed during previous soldering attempts as there was no DC short or continuity from the SMA center pin to the ground. Could this be the cause? I'm not sure, and if anyone knows the purpose of this inductor here, let me know in the comments. Meanwhile, I decided to try a different inductor in parallel with the antenna port and tested the transmission. With the new inductor in place, the output power returned to approximately 2.5 watts, so the inductance might be too high. I'll solder this in place until I can source a 4.7 microhenry inductor as per the original schematic. After unsoldering the faulty inductor and replacing it with the new one, I turned the radio to the local VHF repeater and received an echoing notifications in real time. It was a success, though working on SMD components without proper equipment is a real challenge. Also, I got an opportunity to have a live QSO while troubleshooting from an incoming station via Echolink.
V2 VPF, this is V3ZAG. Very good morning, dear Vilas sir. I'm able to copy you 5x9. Actually, I was doing some troubleshooting on my radio and I thought I should give a call. So, anyway, thanks for the report. I'm also able to copy you 5x9. That's a critical report from my end. Over to you, V2 VPR, V3ZAG.
Very clear audio. Our VHF repeater is doing a good job. Provided you give a good power signal and looks like you are giving towards the repeater and putting a good power so that such a wonderful audio can come out. Because receiving antenna needs maintenance. Right. So how are you? How is everything?
So that was a short and wonderful QSO, and I got a good report from the peer station. Finally, I checked the HF reception by directly connecting the antenna to the HF port and tuning to FT8. The small VHF UHF dipole antenna seems to work well on HF as well. This troubleshooting process was an interesting learning opportunity, and I hope you found this video helpful. Thanks for watching 73s.